Hello, my name is Brandon Forte. For this number talk, I've designed a grade 5 fraction routine that's going to connect mathematical reasoning to rhythm and music. The goal for the students is to use mental strategies to combine fractions and explain how these fractions can make one whole. In this musical context, one whole is going to represent one complete measure of music, as you can see on this slide. Um, so I'm using Google Slides. It allows me to present each expression visually, reveal the problems one at a time, and include both the fraction and the rhythm representation. Excuse me. Students can also revisit the slides when they need additional processing time or visual support. Um, and during this routine, my role is not to just demonstrate one required procedure. Instead, I will provide think time, record multiple strategies, and ask questions that'll help students explain and connect their ideas. So, before we begin here, let's talk about our expectations for our number talk. All right. So, students are going to solve each problem mentally and remain silent while everyone is thinking. And then when a student has a strategy, they'll place a thumb at their chest. Okay? If they develop another strategy, they can raise an additional finger, like so. Okay? These hand signals will allow me to see who's ready without students shouting out answers or interrupting another person's thinking. All right? And with this concept, students may be able to agree, disagree, restate, or add on, but they have to be able to support their responses with mathematical evidence. All right? So let's get started. So we have three expressions, and I'm going to walk through each expression here. So the first expression you see is 1/2 plus 1/4. Okay? So I would ask students to study this expression first silently. All right? And then after giving them their think time, I would ask them to solve it mentally. And then when they have a strategy, they would show a thumb on their chest. Or if it's another student, they would add an additional finger when they find another method. All right. So my response would be, I see that several students are ready. Some will have their thumb up like this. Others may have their thumbs up like this or like this, depending on if there are multiple strategies that present themselves. So I would ask, what answer did you get? And a possible student response would be, I got 3/4 because 1/2 is the same as 2/4, and 2/4 plus 1/4 gives you 3/4. So then I would repeat what the student said. So you renamed 1/2 as 2/4 and then combine the fourths. So then I would write, for example, 1/2 equals 2/4 on the board. And then I would replace that 1/2 with the 2/4 and add it to the 1/4 to get 3/4. All right. And then I would ask, can someone restate this strategy in their own words? And then a student response may be that the student made the equivalent fraction on both, made equivalent fractions using the same denominator. Okay. So that would be the concept, using the same denominator. Um, and then I would follow it up with that by asking, how does this denominator help us in this expression? So it would tell us that if the common denominator is 4, that tells us that this whole that we're looking for, or in terms in music, this whole measure has 4 parts to it. Okay? So then I will move on to expression 2. Same process, allow them to have think time. Now at this point, because they've already gone through the first expression, students may raise their thumb or show multiple fingers a little bit quicker, because most likely they will probably just lean on the first expression to figure out the second expression. Okay, so I would acknowledge the students. All right, what answers did we find? So a possible student response is, I already knew that the 1/2 plus 1/4 equals 3/4. So 3/4 is 6/8. So 6/8 plus the 1/8 equals 7/8. Okay, so what this particular student did was use the strategy of the first answer combined it, and use the first answer to bring it up to an eighth, and then added it on to the last part of that expression to get the solution of 7/8, right? So obviously I will write all this on the board and then ask for a different strategy. So obviously a different strategy would be just instead of just taking that answer and add it and bringing it up to the common denominator 8, there might be other students who bring everything up to 8. For example, another possible response would be I changed everything to eighths. So 1/2 is 4/8 and 1/4 is 2/8. So 4/8 plus 2/8 plus 1/8 equals 7/8. And I would say, okay, great. These are two good concepts. So I would follow it up by asking, how are these strategies similar? And the student response can be, they both use eighths, but the first strategy combined 1/2 and 1/4 before changing the answer into eighths. Okay, just to kind of get their wheels thinking. So by the time we get to the third expression, right, they now have two possible strategies that they can use to answer this bigger expression here, which we have 1/2 plus 1/4 plus 1/8 plus 1/8, right? So once again, give the students think time, all right? And probably by this point, the think time is going to go quicker because they've gone through two solutions. So you're going to see a bunch of this, right? And so I would ask, okay, what answers do we got? All right. So I got 1 whole because 1/8 plus 1/8 equals 1/4. Then the expression becomes 1/2 plus 1/4 plus 1/4. And then the 2/4 equals 1/2, and 1/2 plus 1/2 equals 1 whole. So in this strategy, they added the smaller pieces to get to bigger pieces, right? So they add the eighths and then they add the fourths to get to the halves to eventually get to 1. Okay? Another strategy. All right? So then I would ask, hey, does anybody have another strategy that they present? And another possible response would be the strategy that was used prior in the second example of just having all the expressions become eighths. So I just broke up everything into eighths, and then when I added it all together, I got 1. So in this case, both strategies reached 1. One student combined familiar fractional parts, while another student used a common denominator. Okay? So now that we have all these possible strategies, I want to now compare these strategies side by side. So the first method uses benchmark relationships, right? So students recognizing 2/8 makes 1/4, and that 2/4 makes 1/2, right? So because they know these common fractions, it's easier to solve the problem, right? The second method that someone use, probably I would use, is just put everything under a common denominator, so that way I can just do it across and be done with it, right? Shown in the example in front of us. Another student could also use a number line, right? So instead of just using equations, can create a line. One line can be 0, the other one line can be 1, and they can break it up into 4 parts or 8 parts and do the addition that way to get to 1. And there's also another representation, which could be a rhythm model, right? So if I presented a rhythm model of 2 beats plus another beat plus a half a beat and a half a beat, that would make 4 beats. I know that doesn't make sense right now, so let's go back to our example in the beginning. Okay? So let's just remind ourselves of what we're looking for. 2 beats plus 1 beat plus 1/2 plus 1/2 equals 4 beats. So if we're talking about 2 beats, okay, if this is what we're counting by, all right, if I were to say these are 2 beats, okay, then 1 beat is 1/4. So 2 beats would be 2 of these, right? So 1 plus 4, 1 plus 4, okay. And then you have plus another one of these. That would make 3 beats, right? Which is shown. And then we have halves, all right? Half beat. Now, this is very deceptive because some would think that because this is one half, right? Because it's asking for a half, that okay, I'm just gonna grab this, and they would be wrong because they would go over the number 4. So what we'll be looking for is half of this value, which would be this. Okay, so I'll have to go through that rhythm one a little bit slower, but eventually they would get to this answer more efficiently. And really, after going through all these strategies, my question would be, which method feels the most efficient for this problem and why? And you're not really asking for the sake of a correct answer, but you're just asking for the sake of trying to really gauge the students' thinking and trying to figure out, okay, what strategy makes the most sense or makes the most sense, maybe based on speed or based on understanding what's happening. But what's most important is students having that space when you ask that question to be able to justify their strategy more than anything. So, throughout this routine, I use talk moves, right? So, um, instead of confirming, I ask questions. So, how did you see the whole? Or you can ask the question of, can you explain this strategy another way? Or you heard me ask the question of how are these strategies connected? How are they different? You can also ask questions who agrees, disagrees, or want to add on. And you can also ask the question of how the evidence show that this total is one whole. Now, you're going to have some students that are hesitant to express, and you're also going to have diverse learners in your classroom, right? So you can provide added silent think time. You can also add sentence frames. You could also split students off into 2 and allow them to kind of rehearse their explanations so they can feel confident when speaking. So, for example, sentence frames can be, my strategy was blank because, or I agree with so and so because, or the 2 strategies are connected because. And not only they can, speak their strategies, but they can write their strategies, draw, clap, sing, or even point to a visual model. You just want to know that students are reasoning, they're justifying their answers, and they are connecting the representations. So, the close routine, I will give them an exit ticket, right? So, because they've been working with 2, 4s, and 8s, the exit ticket would be something that maybe if you want to move to another part of your lesson, or if you're closing out this lesson, they're moving to another class, they would have to be able to solve this exit ticket mentally. So you see the problem in front of you: 3 8s plus 1/4 plus 1 8 plus 1/4. Okay, so in their exit ticket, they will have to explain out of the 4 strategies we went over. They have to explain one of the strategies that they used and got to whatever solution, and then they need to prove that they have to show their work, right? So they have to prove that their sum equals one whole, right? So if students are reading quickly, they'll already see the answer, and they have to prove that by using whatever strategy they want to use to get to one whole. All right. So to look at the adaptation to music, I could also call this a rhythm talk, right? So if I were just looking strictly at music, students can analyze a 4/4 measure, and then they could clap 1, 2, 3, 4, or count the rhythm. I did both at the same time. Write the equation, and then compare ways to fill the measure. So, for example, if I had them do 1 and 2 and 3, right? I give them eighth notes, right? So since I gave them eighth notes, and just so you know what an eighth note is, let's go all the way back. That's an eighth note, right? So 1 and 2 and 3, right? So 1 and 2 and 3. They will have to figure out how to write the 5/8 notes, and then of course there's no rest shown in this presentation here, but figure out how to fill out the rest of it. Okay, am I gonna write an extra eighth note, and then um, and then two quarter notes or a half note? They'll have to figure it out. So now instead of just trying to get to a solution, they now have to fill in blanks, which I think um, will help them in terms of being able to read different rhythms, but also know that despite whatever the rhythm is, it all has to be able to equal one. So this number talk supports several standards for mathematical practice. It supports 1 through 8, but the two that's supported here in particular are 7 and 8. So for 7 and 8, students are looking for structures by recognizing that 2/8 makes 1/4, 2/4 makes 1/2, and 2/2 makes 1 whole. Right. So they're taking their smaller pieces and building to a whole. Okay, and then for number 8, okay, students are expressing regularity and repeated reasoning by using earlier answers and relationships to solve later expressions more efficiently. Right. So they took one answer, plugged it in, got another answer, plugged it in, and was able to complete the solutions uh, that way. And so these would just be reminders, really for the teacher. So to ask these questions again: what structure did you notice? How did the earlier problems help you? How does the rhythm model prove that the sum is one whole measure? All right, and so these are just notes for me, just so y'all can see that not only I need to put my recording link here, but also that I covered all these areas in my checklist and my PowerPoint. So, chapter 4 of teaching outside the box gives us the structure of this number talk. It includes the silent thinking time, it includes the related problems, the multiple strategies, student explanation, and teacher facilitated discourse. So, I hope you're able to use this in one way, shape, or form. And although it was probably technical for our context as a class, I hope if there are any music teachers in our class that you can take this and make it super super fun, but also it allows the kids to really engage. So, thank y'all for listening to my little lesson here. All right. Look forward to looking at y'all and see what the response will be. All right. Deuces.